Ladies and gentlemen, live from London, it's 3ds Meetup TV.
Worse than COVID, I think.
Yeah, just a bit. Good evening. Good evening, everyone, and welcome to 3ds Meetup London. 3ds Meetup London and the Internet. Tonight we've got a special show. We have dedicated the entire evening to Mars. Before we get to that, though, I'd like to take a moment to introduce presenters and panelists. First of all, I'm Joshua Newman. Not that Simon, would like to go as well?
Oh yeah, I'm Simon.
Anyone else? Olga Bass, Nigel Hunt, Emma Fairchild, and our regular guests, Fabio Palvelli and Jason Bergeron, and also Tom Spall, who I forgot to mention there as well. Now tonight we've got a really exciting show. We are going to kick off with Xavier De Kestelier and his project for NASA about building a habitat on Mars. We will then hear from Clark Denman and, if I got that right.
And James, yeah.
Sorry, James Lehman. Sorry, did I get that right, Clark Denman and James
Yes,
Lehman?
no, sorry, I've been naughty and left it off, and sort of leaving everyone guessing.
Right, I don't have my note. I usually have more screens than this, and I don't have my notes in front of me. They're somewhere here. And we will then finish the evening with Wayne Robson. So to thank our sponsors, before we get started, Autodesk Media and Entertainment, Sonar Software, V-Ray Chaos Group, Blue GFX, Yellow Dog, Render Recruitment, and CV Press. Have I left anything off there, Nigel? You're muted, Nigel.
Nigel's just sorting out the audio because it's a bit echoey on YouTube, so he's just having a look at that.
No, I'm not. I muted myself because let me mute myself.
I think maybe if everyone who's not participating could mute, might be a good idea as well, please. So is there any, has anyone got any news tonight?
So let me unmute. There is one that one of our sponsors has asked us to mention, and that is the there we go.
Short news segment tonight.
Sorry, I'm going to interrupt. Sorry, Nigel. There's a problem with the audio. It's very echoey, and now there's no sound on
I think
YouTube.
there's no audio. Yeah, there's no audio. Since the building Utopia thing came up, the audio went off.
Going well, right?
I guess we should be talking while we're trying to fix this, otherwise no one's going to know if the audio is
Yeah,
back.
if it's echoing or not, yeah.
Is anyone listening to the YouTube feed?
I am, yeah.
It is. It's back on after the building Utopia thing came off,
It's,
Okay.
but it's
you
echoing.
can hear it now. It's just echoing a lot. Oh,
Now there is sound coming from YouTube.
Okay,
I think it's okay now.
we're good to go.
Yeah.
Right. Okay. So studios looking for new artists. I know that Asymmetrica are hiring. I don't know if anyone else has anyone else heard anything about jobs?
Yeah, I think.
Do you wanna?
Setchy Smith were advertising, I think, for
Right.
digital artists.
I don't know
Okay.
if people heard the thing about the building utopia because you were muted
Yeah,
during
It was mute. There was no sound when the building utopia thing was being discussed. Nigel.
Shall we talk about it again?
Double plug.
Let's just say, go check out CG Architect and look at the competition, or go to Chaos Group. I think it's a reminder to the community that it goes for another month.
Can we also say something about the competition that we're doing?
Yeah, please go ahead.
Over at D2, we launched the competition a couple of days ago. It's called Digital Favelas. It's done in collaboration with our friends at Matte Paint, together with Ander Alenkar. It's a competition where we ask people to create an image based on the topic of digital favelas. There are models that can be downloaded, so even if you don't want to participate, you can still get free models. These models were made by Ander. But the competition is a lot of fun. We have prizes from our friends at Sinai Software. We got prizes from our friends at CG Architect. Jason, help me out here. What else do we have?
There's some, and on the Matte Paint side, they are offering as well some subscriptions to their Matte Paint community. If you don't know what mattepaint.com is, it's basically a place for matte painters to get together, and they have a subscription based on so for photography that can be used for matte painting. They are offering subscriptions as prizes, as well as they have a separate sponsor, Big, Medium, Small. I don't know if you guys know that. That's also this from Yama. What's his last name? I can't remember. Yabaravev Yama. You probably know who he is. Where they have these really high quality assets, and they're offering something. It's not clear exactly what that price is, but some models from that. So could potentially be other sponsors coming, but at the moment, that's where we are.
Yeah, woohoo!
Yeah, so join us.
Tonight we're going to talk about Mars bars, but it turns out to be the other Mars. And so I'm very excited now. No Mars bar for Fabio.
Go back to gallery view. Right, Josh, do you want to give us the itinerary for tonight?
I think I did. Shall I go over it again? Maybe the sound wasn't working very well. I think we're ready just to leap on in with our first guest, if you're ready, Xavier. Xavier De Kestelier heads the design and technology team at HASSELL International, and he is going to talk about Martian habitat. Xavier, over to you.
Thanks, Josh. Let me just share my screen here. Can everybody hear me? All good? Yeah? Cool. Well, thanks for having me here. And to start off the evening, talking about a Mars habitat that we designed. Maybe a little bit of background information first. I work for HASSELL Studio. We are a fairly large international architecture, interior design, and landscape architecture firm. Originally started in Australia many years ago. Now we're also operating from Asia. We have a London studio with about 60 people, and a couple of years ago we also started a San Francisco studio. Our work is quite a variety of work, from small interiors to big infrastructure projects, museums, interiors, and so forth. So it's quite a wide range of projects. Myself, I am the head of design, technology, and innovation at HASSELL, and that's a global role. So I do that for the whole practice for all of the studios. This is a little snapshot of kind of what my world looks like on a day-to-day. Under my remit is anything to do with design technology, and that can be anything with BIM, anything with visualization, computational design, digital fabrication, and even physical model making. I think it's all part of that one spectrum of design technologies. And we also do innovation, which means we often work on, now and then actually, we work on very special projects. And today, really, I'm going to talk about that, about one of those very special projects, which is this one. It's a Mars habitat that we designed for NASA, and this was part of NASA's Centennial Challenge. Now, Centennial Challenges at NASA are ways to bring in industries that normally don't really get involved in space, such as architects, for example. So we were very keen to join that. That's about almost 2 years ago that we joined it, finished it just over a year ago. Now, once you get a project like that, a brief like that, how to design something for Mars, for those first humans to settle in Mars, where do you start, right? Well, as an architect, you often sometimes say, well, look at precedents, right? So what are our precedents? Well, this is a precedent. This is the largest space habitat out there for the moment, International Space Station. It's an interesting one, but the moment you start looking at it on the inside, it looks all very engineering, right? And there's very, well, it's hard to think there are any designers or architects involved in organizing this space. And you're right, there are very few architects involved. What you get is a very much engineering systems where humans are just another system. I would say another kind of operating another system within this big machine. We're really part of the machine. So maybe not a good example to start to think about a space where you want to live for a long time. So of course, when you think about designing for space, the first thing that comes up, of course, is sci-fi. And it's very tempting to go and say, well, let's look at sci-fi images. Let's browse the net and kind of think about all those great shows and great movies from the past, Star Trek, Space Odyssey, amazing interiors, Alien, and one of my favorite ones, Moon. But let's not forget, these things are really stage design. This is science fiction. What we're trying to do is really science fact. So looking at references from science fiction was not really the right thing to do. So what we try to do is look at other references. For example, look at other architects that might have worked in space for real. One is this woman here, Galina Balachova. She was the only architect, the only woman architect, actually the only architect to work for the Soviet space program. And she was involved in, for many, many years, to design the interiors. This is one of the interiors she designed. This was for Soyuz orbital module. And I just love these little drawings because they really show something very, very different to what we see in the ISS. You know, you see some wooden veneers, you see some fabrics, you see some pictures. You know, it looks very homey. It looks almost something where you would want to live in. She also worked on this. This was actually exhibited in the Science Museum in London a few years ago. This is the Russian lunar lander. An amazing looking machine, I think, that never landed on the moon, of course. The Apollo missions were first, and the Russians actually in the end were never achieved to do that. And look at the machine, and then look at the interior drawings of what she's done. I just love how kind of normal and almost you know, non-technological they are, and non-machine-like they are. So I think there's something to learn from her. She also works on the Mir space station, where she did some of the interiors as well. Just look at these drawings, just amazing work, I think. Now, another person we looked at to get inspiration from is Raymond Loewy. Raymond Loewy, a famous industrial designer, American industrial designer. he got involved in NASA quite a bit, and he was really the first designer to be involved in any of the programs at NASA. Now, the big project that he got involved in was Skylab. Skylab was one of the first orbital space stations for NASA, and they brought him in, and just another kind of wonderful drawing by Raymond Levy, and the space engineers, were a bit skeptical. So, what is a designer going to do, right? Is he going to choose the color or something like that? Or what is he going to do here? But he did indeed choose the color, but he did many other things as well. And you see that the most important things that he'd done, you can see here on this image, 3 astronauts in Skylab. First thing he did is he gave each of the astronauts a private space, right? The engineers that designed Skylab did not think the astronauts needed their own space. Imagine being in the same capsule, because there was only one major capsule, with all the other astronauts the whole time for weeks and months at a time. So he gave them their own little space. Second thing he did is design the table. You might think, well, what's so special about this table? Well, originally the engineers did not design a table. There was only little kind of trays that flapped out of the sides of the space habitat on the inside, of course, and you could sit there and eat, and you were not actually facing the other astronauts. Imagine that, having to not be able to have a meal and have a conversation about what you did that day, right? So he did that. He actually designed it, but he actually made sure there was a table. The third thing he did, which I think is absolutely extraordinary, is that he did the window, and you can see it in the background, the little window. Now, that in the original design, again, the engineers did not think it was necessary to have a window. So imagine, as a Skylab astronaut, going hundreds and hundreds of times around Earth for weeks and months, and then never be able to see this, right? Extraordinary. So, learned quite a bit from that, I thought. Now, this is kind of like precedence. So once you kind of start designing for Mars, what are we going to do? Well, I think instead of kind of looking at references, what we really want to do is look at first principles and understand what is the environment there. What are we really, really dealing with? First thing to do is see where it is. This is a picture, the famous Earthrise picture. It's a picture from taken from moon orbit towards Earth. Now, if you do the same picture from Mars, this is a picture taken from the Curiosity rover. Looking back at Earth is just literally 1 pixel on this image. Now, the distance from Earth to Mars is about 1,000 times the distance from Earth to the moon. So it's extremely far, which means that it's extremely expensive, whatever you take there. So the trick is to travel really light and to travel really compact. Remember that, light and compact. We go to Mars. Other things that are interesting about Mars. You have weather, you have an atmosphere, you have storms. You actually have sandstorms that can last months and are completely planetary. So you have storms that completely go over the whole Mars planet. Another thing, now Earth has this fantastic thing that we have magnetic poles. Magnetic poles actually help Earth to protect itself from radiation. Radiation from the sun, radiation from the cosmos. It's a really important thing. Because on Mars, we do not have that, which is a bit of an issue, because we get really high radiation exposure for the astronauts. And this is really the main thing that our astronauts will have to protect themselves, is from this really harmful gamma radiations. So Mars, what else is there, right? Well, we have an atmosphere. It's a very thin atmosphere. It's mainly CO2. It's really cold. It's often roughly around -70 degrees Celsius. The hottest it ever gets is, I think, about 10 or 20 degrees. So it's really cold, thin atmosphere. Oh, and it's 1/3 of the gravity on Earth. So that's kind of what we have. Now, our design is really based around the following concept. It's based around 2 things. The internal pod, which you just see here, kind of like lovely inflating and unfolding. It's a lightweight system. It's made on Earth, and it's brought with the astronauts to Mars, where it actually inflates itself. It also holds the pressurized volume. It holds the atmosphere, the oxygen for the astronauts to breathe. On the outside of that, we have a big shell. You see this brown thing, this big mass. That really is there to protect the astronauts from radiation. The best thing really would be to live in caves, right, as an astronaut, because you need mass to really protect yourself from the radiation. Now, remember what I said. We need to travel light and compact. We're not going to bring masses of concrete, of course, with us. So we'll have to do something else. What we're going to have to do is use local materials. There's not much that we have there, but the only thing we have is regolith. And regolith is what we call Martian dust, really, right? And there's lots of that. And what we're going to do with that, well, we're going to use that to 3D print a shell structure under which our own kind of self-made cave to live under. And as you see, we have all these little kind of almost ants 3D printing this. These are small, fairly small robots, because of course we're not going to bring a massive 3D printer with us. That would be a bit ridiculous. And as you can see, these are our robots. 4 types of robots. One finds the regolith, the second one digs it up, the third one brings it to the side, and the fourth one is actually binding it together through microwave technology. Now, let's talk a little bit about how the habitat is built up. Of course, if we have on top, we have the big shell structure, protects ourselves from the radiation. Underneath, we don't just have one of these bubbles, these pressurized bubbles, inflatables. We have 6 of them, and they're all connected with a connector pod. And as you see, each of these connector pods then becomes either suit ports, which are ports where the suits are on, or it can be an airlock, or the third thing it can be is a connector to the rover, the Martian rover. Each of these pods are quite similar, right? They all have a kind of a radial grid, and they all kind of have kind of the same topology. But they're all quite different. We have one of them is our living quarters on the bottom here that go around anti-clockwise. We have our the gym plus the private rooms. We have a small bedroom, each of the astronauts. We go up, we have our lab, we have a greenhouse, we have a workshop, because it's really important to be able to fix stuff. And then we have storage space as well. Now, you can kind of see that the whole thing is really built out of these racks, these radial racks, and they can all be something different, right? They can be storage, they can be a room, they can be a kitchen unit, and so forth. Now, that system is something that we kind of developed ourselves, because we thought the way the ISS is built up is spatially not that great. Right. ISS is built out of these kind of big cylindrical volumes, where typically you have storage on the bottom and the top. They still have bottom and top. And on the sides, you have these racks, which are science racks, right? But those aren't used all the time, right? It might be that an experiment is set off and then an astronaut leaves it for maybe a day or hours or so forth. So in the end, with this kind of topology, what you get is lots of corridors with science racks. So we thought it could be much better if we find a system where we have a radial system that with racks that really could open up and close. And you can kind of see that here. This is our science module, the lab module, where you see astronaut there doing some work. He could then actually open it up and get into another one. It's very similar to what you could find in library archives, you know, these big kind of shelves that you can move around. Very similar to that. And a shelf could also be maybe a greenhouse shelf where you grow some plants. So it's the same setup, but the infills are each time slightly different. And here, the same thing. This is a gym and also the private rooms. Now, what I really want to do today is, it's a little bit different from how I normally do this talk. I really want to talk about all the visual artists and designers that really were involved. So anybody that had anything to do that as a visual impact of the project, I want to talk today about that today. The biggest one, the biggest collaborator of the project was, of course, Lightfield, but you will hear all about that from James and Clark after this talk. So I'm not really going to talk about Lightfield too much, because they have their own half hour to explain how they actually created the video that had to be produced for this project. But I'm going to talk first about a few other collaborators and how we kind of worked on getting this kind of overall view that we really set out to do, how we could create the overall vision. For renderings, we worked with Agnet from Imigo. And you already kind of see in this first render is that we learned a few things from Galina Balachova, because as you kind of notice, we have these veneers. So we use very kind of tactile materials. There is actually a veneer bamboo floor, which we imagine you could potentially even grow on Mars and actually use that as material in your habitat. So really trying out some different materials that you normally see in space habitats. Also, the most important thing, of course, here is that view. Remember, Skylab did not have a view, a very small view. We want to make sure we had that, whilst at the same time protect our astronauts from the radiation. And I think in this image, it really shows that we really tried to set out to create an environment where we couldn't imagine ourselves living, right? We really thought that living on Mars, as humans, we have to thrive, not just survive. Because at the moment, astronauts living in space, it is a pretty hard life. But at the moment, most of the astronauts live for about 6 months in space. These missions take 3 years and more. So we thought that was quite important. The interesting thing about this image was, and it actually made us change the design slightly, is that Annette did a little trick in the foreground. She put all our robots, all our 3D printing robots. We didn't really ask her to do that, but she thought it was a good idea. And I was kind of shocked because although I thought it looked great in the image, I was shocked myself because suddenly we created the first boneyard of used robots on Mars. That's not the right way to do it, right? We can't really go to Mars, and the first thing we do is create our own dump. So we actually thought of that, and we completely redesigned the robots because of that reason. So we made them modular. So each of the robots now is not its own machine, and once it stopped digging, the digger has no use anymore. No, what we did is we designed a system of almost Lego block robots that could create different types of robots. One of
Yes, yes. Well, I think so. Olga.
Yeah, as well,
Recognised from our crossing of paths. Yeah, we get around. It's Do you know what? How I got my job at Foster's was actually through these talks. I was advertising like our visualization department needs a job. I met Gamma. I didn't actually even apply. Gamma grabbed me in, and then before I knew it, I was offered a job. I was like, all right.
You were working. You didn't even know what happened.
And then, yeah, 9 years later, I finally.
Well, okay, guys, we're back. We've got sound again.
Right.
Cool.
So we're really sorry to interrupt your stream, but if you could pick it up again from this point, that would be fantastic.
Of course I can. So I think where I was is that we worked with Agnet from Imigo on these images, and what we really try to do is really get some of the spirit of Bolachova in here, and using some different materials. So as you see, we used some bamboo veneers, right? Why not create more tactile materials that you would have in your living room, right? So and you might even need to take them with you. You could potentially grow them on Mars as well. You can see in the background there's some bamboos being grown. The second thing important in this image, of course, the view, right? Being able to create a large view out, learn their lessons from Skylab, not just to the Martian environment, but also to the rest of the habitat. Being able to see another person that's not in your own space. I think that's actually quite an important thing to be able to do when you're going to live there for more than 3 years. In this image, you really see, I think, we really wanted to show is that it's a nice place to live, right? It doesn't have to be hardship. As an astronaut, you don't just need to survive. I think we need to thrive on a different planet. And there's a really interesting detail I want to talk about is you see in the front right-hand side, that are those robots that were 3D printing our shell structure, right? And Agnet did this thing, she said, well, you know, once you're finished with the robots, they have nothing else to do. So they made this kind of heap of, you know, discarded robots, bit of a boneyard of robots. Although I really love the image and the idea of the discarded robots, it was a bit shocking for me because we're going to go to Mars, and then the first thing we do is create a dump of robots. You know, we have to, when we go to Mars, we have to think about it in a completely different way. We have to really think about sustainability in a completely different way. And we need to think about reusing and recycling everything we have. So we actually went back to the drawing board and we redesigned these robots. They're not 4 types of robots anymore. They are a system of robots. It's a Lego system of robots. You have different blocks that then can create different types. One wheel together with a battery pack might become the robot scouter, the scouter for Regolith. Add a few more wheels and a few diggers, and it becomes your Regolith digger. Add more batteries, more wheels, and a printing head, and then maybe it becomes your printing system. So really that idea of recycling and reusing, being much more resilient with a system, we try to bring into every aspect of the design. We worked with Agnet through Bluescape, which was kind of our online pinup board, where we're able to kind of do markups. So we use that with the guys from Lightfield as well. I think you guys will show that later. As you see here, the markups and the references we use, we did again not really use references for space. We really used that workshop references, what a workshop looks like on Earth. I think that was really important to keep it really science fact and not science fiction. And this is that workshop that we have. There's a lot of detail in here, and there's actually all the parts in here really tell a story, and there's 2 stories I can tell about this. The left-hand side on the background, that's a 3D printer, a Delta 3D printer, printing some big parts, and I'll explain that in a minute. On the right-hand side, you see a sewing machine, right? And you might wonder, like, why do we need a sewing machine on Mars? Well, think about recycling and reusing to the extreme. And what if we would reuse the parachutes that we landed on Mars with? You know, Mars will use, landing on Mars potentially use parachutes. So why not reuse that material for something else? Why not use that to make the clothes for the astronauts? Now, the great thing is I knew of a guy that exactly did that, and that's Chris Rayburn. Rayburn started his label in Hackney many years ago, and that's what he does. He is really extreme in looking at how we can reuse materials. And one of the things he does is really he makes clothes from used parachutes. So I actually didn't know him before this project. I basically called up, went to their store in Hackney, walked in, talked about I'm an architect and I'm designing a habitat on Mars, and somehow they listened to me. And about a day later, I was able to come back, and Chris was super nice and allowed us to use all of the garments they had in their archive to really use for our photo shoots, for our green screening, for the images. So yeah, super nice of him. That was not knowing us, and then be able to kind of give one of their archive pieces for the shoots. And our collaboration continued then, really, because afterwards, and when we continued the development of the project, he really got inspired by our design, and his 2020 spring summer collection was based around Mars and our Mars habitat. And that's it. That's one of the pieces they made. It's made out of blankets, emergency blankets, these pieces. Other pieces have prints of high resolution NASA prints from Mars. And other pieces are then made out of the parachute material as well. And you know, and of course it's a great thing to get a fashion designer involved, because then you kind of, you know, they make them t-shirts with your own design on, right? So that was a lot of fun to kind of get him involved. The second thing we did, and remember that kind of interior shot I showed, we had these big sofas, right? These big chairs and all that. For that, really, we worked together with Manuel Jimenez Garcia, a good friend of mine. He's also an architect, and he has a company called Nagami, and that's a furniture design and fabricator. He's based just outside Madrid, and this is his factory. He actually has a larger factory now. This was a factory he had last year. He expanded, and you see all the furniture in the background, all designed, some of the pieces designed by himself, and 3D printed by these large industrial robots. Now, and he designed all the furniture for the habitat. Right? You might think, well, isn't that a bit crazy? You told us in the beginning that we need to pack light and compact, and we're going to bring these big 3D printed pieces. Well, the thing is, of course, we're not going to bring them. We're going to print them there, and we're going to use waste material. What we're planning to do is use recycled plastics from science experiments and from food packaging. So there will be waste. So why not reuse it to create the furniture that we will be using? And it didn't just stay as renderings. Of course, we did it for real. So this is Manuel printing one of those air chairs, they're called. You can actually buy them now as well. If you go to nagami.com, you can see them there. Printed in one go over a few hours in one thin shell of plastic. Now, and you might think, well, Xavier, you kind of made them look very spacey, right? Yet in the end, they looked very spacey and they looked very transparent. But we didn't actually plan out to set out to do that. The transparency is because of reusing the recycled plastics also here. And the design of it is this kind of one smooth curve, because we have one continuous printing profile. A continuous robot can continuous keep on printing, and that gives us the most efficient shape and fabrication method. And you can see that here, one of the finished products. And just to prove you that this is not a rendering, it's not rendering, we have a person in there. So it's really just kind of floating one piece of plastic, of recycled plastics. Another thing we did is we worked with Juan. Juan used to work for us as well, but then he kept on working on this particular project. He's an architect, and we got him involved to do some drawings. right? Drawings for what? Well, for this project, I kept on saying this is not science fiction, it's a science fact. To make it really fact, we collaborated with Cranfield University and together with the students of Professor David Cullen. Now, he has a master unit that he teaches, and the students are all space engineers. And what they did is they helped us with looking at two things. First, looking at the system engineering, looking at how much energy we need, how we can get the energy, how much water we need, how we're going to recycle it. So they were always there to always fact check whatever we were designing, that it would actually be a good proposition. The other thing they did, they looked at the mission architecture. The mission architecture is really looking at how we get stuff there. The most important thing, how are we going to get our habitats on Mars? And you might have seen kind of these graphics, right? These graphics that you have from NASA or from ESA, looking at the mission architecture. I think this is the Apollo one, looking at how, getting into lower orbit, which bit comes off, which bit turns, which bit then lands. It's quite a complicated dance of different maneuvers. So there's kind of the graphic explaining how stuff gets there. But on the other hand, I also want to show the architecture. And I got a bit of obsession with future systems, and particularly this book showing Jan Kapliczky drawings and drawings of his design. And I really love how clear and minimal they are. They're just line drawings, and I still love line drawing as well. So I gave this book to Juan. I said, I know this is kind of what we're after. We want something like this, but also mission architecture. And then he came up with these two drawings. The drawing on the right-hand side, you've seen part of it already, really explains the architecture, what will be there, how all the bits come together. But on the left-hand side, we really have the mission architecture, explaining in a very graphical way how we would get all our bits to Mars. And that's really why we needed a visual artist for, because of course the Cranfield engineering students, they had all the numbers and all the spreadsheets, but you couldn't present it in an interesting way. So we kind of asked Juan to do these two panels for us to really encapsulate the whole project in these two drawings. And one of the submission materials we had to do for NASA was a model, was a physical model. I went back to one of my old colleagues at from Foster's, Sam Morgan, who's at Base Models now in Battersea. And well, the great thing is that whenever you come with a space project, everybody really gets excited, which is a good thing. They also got immediately excited about this project. It was great working with them because, we already had some of the renderings done by that stage. And what we really want to do is make sure this was going to be a presentation model. This was going to be a model. This was not a design development model. This was not going to be an abstract model. What we really want to do is get as much detail as we could in there. You kind of see there's some of the details here, all these kind of etched little science racks in there, all detailed to like minuscule detail. It was a combination of really interesting techniques. We used milling, laser casting, etching, 3D printing with different kind of techniques, vac forming. I think every kind of interesting model technique came actually together in this project. It's quite a difficult project to present because most of the habitats are kind of stuck underneath that kind of regolith shell. So we decided only to do half of it and then open it all up so you could almost play with it. You could take all the hoods off of all these little habitat pods. And then we were really, really lucky that we got invited by the Design Museum to become part of their Moving to Mars exhibition. That happened all just before COVID started. I think the exhibition was finished in February last year, so I hope some of you saw it. It's now moved to Stockholm, where it is in the Science Museum, and hopefully in a few months it will open there. The Design Museum asked us to go and build one of our pods. So we're super excited because now we didn't just have a design anymore, we had to get some construction drawings out as well. And we wanted to capture that in the right way. For that, we worked with NARA architectural photographers that we know. They often kind of take pictures of more kind of experimental pavilions and architecture, and you know, they were absolutely the perfect fit for that. The great thing is they were actually able to come twice, because we had a bit of an issue. The big pot, the inflatable pot that we designed, was a few weeks late. So these are the pictures without the pot. But what you do see is that we created this huge wall, this video wall, that we could have this continuous view onto the rest of our habitat. There's some work that the guys from Lightflied also did, but I think they'll explain that in a bit more detail. And in the front, of course, the furniture designed by Nagami. And then a few weeks later, we got a pod. Our inflatable pod arrived from Ljubljana, and we could have Nara over again to take the final shots of this project. And as you see, what we really try to do is to create a space where you would really want to stay, where you would really want to live, but at the same time is super, super practical. As you see these kind of shelving system, that the racks that could open up and radially move. You could open it up, go in, do an experiment, come out again, do something else. So trying to almost kind of test it out, have a prototype how that could work in real life as well. Have a little nap there in the Nagami chair. And so this is the kind of final shot of the project. Again, using different types of materials and just creating a space that we believe would be great to live in. I'm gonna finish it there, and I think what I would finish with is probably the video that the guys from Lightfield created. And if we play that now, it's about 5 minutes, and I think, Josh, are we gonna have a break then? And then Clark and James will talk about the video?
I think we could move straight into
okay, cool.
Clark and James' presentation. Yeah.
Should I stop sharing and then you guys play the video?
I think perhaps if you'd like to finish up, we might take a few minutes for questions. Should we do that before the film, Xavier?
Yeah, I got a couple of questions.
Go for it, Simon.
Xavier, thank you. That was an incredible presentation.
Thank you.
Really, really good. Apologies for the interruption halfway through, but there you go. Never mind. It was nice to see that Naro were involved. They really talented company, and we did a photography workshop with them at HB a couple of years ago. It was really cool. Also, I had a question about you showed a beautiful book about halfway through as a reference for line drawings, and I wondered if you could just repeat what that was, because I missed it.
Yeah, it's a book. I think it was part of an exhibition. It's called Jan Kiplički Drawings.
You're gonna have to spell that to me in the chat.
Oh, I don't know.
And then I'll put it in the YouTube comments.
So he was one of the founders of Future Systems, right?
Okay, cool. Oh, okay, got you. Yeah.
And it's kind of interesting. A co-founder of Future Systems, actually David Nixon, who ended up becoming a prominent space architect. He actually worked after he left Future Systems. I think he was there for 10 years. Then he left. He moved to the West Coast, and one of his major clients was NASA. He was involved in some bits of the ISS, but what he did do, he made a beautiful book on the ISS. It's called The Architecture of the ISS. It's a great book to read, great piece, looking really at it from historical, but also from an architectural perspective.
Yeah, I mean, I love renders. It's my job, obviously, but I've always got a massive soft spot for line drawings. They're always they just suck you in like nothing else can, I think. Anyone else? Anyone have questions? Anyone else?
Yeah, I have a question. Actually, Xavier, I really like your presentation. Thank you. That was amazing. I like this science fact statement that you made. I'm interested. How long does it take once the Martians get there? Once the astronauts get to Mars, how long before they have something inflated that they can get into and be protected from the environment?
You'll see that in the video, actually. But we think, I need to kind of look at the thing again, but the inflatables will be done by the astronauts. So the habitat is, the shell is 3D printed first. Once that is done, the astronauts will arrive. But it should be fairly easy to inflate. So we're thinking it'd probably only take a few days to kind of set up the whole habitat. So once they inflate it, they can then start building up everything from the inside.
Right.
Louis in the YouTube comments has a good question, and he's asked about menu fatigue. And can he ask about catering and
Yes.
kitchen on the mission?
I have a good one about that. So I talked a lot about kind of tactile materials, right? That's something we also kind of knew from the people that live in the Antarctic. I know the kind of I think he's now head of polar operations, John Eager, and he used to be the commander of the Halley 6 base on the Antarctic for the winterization crew. And I had long conversations with him, and he kept on telling me that they missed tactile stuff, being wood, warm materials, for example, in their habitats on the South Pole, but also tactile stuff to eat. And he said, what we did is that we grew, for example, lettuce, not because we needed it for nutritional reasons, but because we wanted something crunchy, right? And if you see what we have a greenhouse. The idea is that we think the astronauts would be growing stuff for them to eat, but not to actually completely have their whole menu taken from that greenhouse. That would actually not be possible for many, many years. So they would bring pre-prepared food from Earth, but they would actually supplement that with stuff that they would start growing on Mars.
Cool. Just interesting because you mentioned the South Pole scientists stuck out there. I read last week that the day after the last plane flies out of the base, they all get together and they watch The Thing, because they know they've got another 4 months before there's any outside contact, which I thought was quite good of them.
It is the best, are the best analogs, those bases, because there is no way in or out. If somebody needs medical attention, it will happen with that one doctor that is on the base. That's it. That's your only shot. There's no way. You can't really get evacuated in the winter from these bases. You can get evacuated from this National Space Station in about a day, no problem. But those Antarctic bases are very tough.
And Xavier, I think I've got one more question from the YouTube comments, and then we'll move on. But Sam asks, how do you feel like designing for Mars and space will inform what life is like on Earth? Obviously, sustainability is a hot topic right now, but do you think anything else will feed back?
Well, I think sustainability was a really big one. It was actually for me personally as well, because I was always kind of, designing around it, but it was suddenly for me designing with sustainability in mind, but once we did this, it really showed us it's life and death. It's not a nice thing to have. It's not a tick in the box of BREEAM or LEED or whatever these things are. We really had to think about it really, really hard. Because the only thing they have, these astronauts, is what they brought and what is there, and there's not much there. So for me, sustainability is really a really big one. The other thing which I'm always kind of intrigued by is how the ISS is still very much divided in different bits according to geographies. The Russians have that part. There's a European module. There's the American module, and although they all kind of live together, they all kind of hang out often in their own sides. So I was wondering, once we kind of move to Mars, can they just call themselves Martians and hopefully forget about the geopolitical backgrounds that they all come?
That would be nice, yeah.
No.
Okay, I'm going to hand over. Thank you, Xavier. Fantastic. Really, really fantastic. Thank you so much. I'm going to hand over to Josh, and he will introduce the next speakers. Thank you.
Before we move on, Xavier, could you stop sharing, please, actually, just so that we get the interview back up? I've got a couple of questions as well. Is it true that true that Mars is also flat?
Well, you can read all these things in our, if you look at a video in the YouTube, we have a lot of flat earthers doing comments. It's quite neat.
What my question is, can you tell us a little bit about how the product has been received generally by the public, and what sort of challenges you faced from any kind of backlash or from?
Yeah. It's, well, the one comment we always get is, well, why do you think about going to Mars? Well, there's so many problems still on Earth.
Yes.
Why do you do that? There's a one thing that always comes up. And why would we all want to move to Mars? And to be honest, I don't really want to move to Mars, right? It's a pretty extreme environment to live in. It's going to be pretty harsh. And I just want to kind of put the analogy again back to Antarctica. In Antarctica, we are there for science. Nobody's going to go and live there. We protect Antarctica very thoroughly. You can't have a cigarette butt and drop it in Antarctica. That's highly, highly illegal, right? So I think we'll treat Mars like we'll treat Antarctica. But honestly, I do not believe that we should use, such as Elon Musk says, that we should all move to Mars and to have like a second backup planet. I don't really believe that.
Great, excellent. Unless there's any other questions, I think what we'll do is introduce our next presenters and play the film, which Xavier mentioned before. We're now going to hear from Clark Denman and James Lehman, the founders of Lightfield. And first of all, we're going to watch their beautiful film. Thank you.
Sorry, let me jump in here. Which film are we going to play? The Mars film, or are we going to play the showreel?
The Mars film, please.
Yeah, we'll start with the Mars film, and then it'll make more sense when we take you through that process, please. Thank you.
Half a century ago, we took our first step on the surface of the moon. Today, there is renewed passion to explore for our next human endeavor. Mars, the red planet, further than any human has ever been. We face many challenges: remoteness, no livable atmosphere, high radiation, dust storms, and extremely low temperatures. Before any humans set foot on Mars, we must first design a protective shelter. We will protect our astronauts from radiation with a thick 3D printed shell structure using Martian regolith, which works great in compression but does not perform well under tension. To overcome this shortfall, we have chosen to construct the pressure-retaining parts of the habitat from lightweight, inflatable pods. They will be made out of high-precision engineered composites that are prefabricated on Earth. Their elliptoid geometry will be able to mitigate the pressure differences whilst optimizing spatial planning. To create the base on Mars, we will use a two-phase approach. In Phase 1, an ecosystem of 3D printing robots will arrive months in advance of any human explorer. They will construct the protective shield for the base by adopting a modular robotic swarm strategy, a plan that allows for redundancies and enhances the odds for success. Intelligent autonomous robots will have interchangeable roles, from battery storage to scout rovers, logistics to excavational, and even 3D printing units, all integrated with multiple cameras and sensors for navigation. They can reconfigure themselves for a multitude of purposes, ensuring prolonged usage beyond the initial build phases. The smallest configuration is the one-wheeled scout rover that uses ultrasonic scanning to analyze the Martian surface to determine the best regions for obtaining optimum regolith. The digger receives the location coordinates and then excavates the Martian soil. It then delivers the payload to the refining assemblies. Here, large chunks of Martian regolith can be processed down to a finer grain and then delivered to the melter robots in situ. They then use concentrated microwaves to melt the regolith and extrude through the 3D printing nozzle. The shell is autonomously 3D printed, layer by layer, over several months by the robotic system. In the next phase, the first astronauts arrive with the habitation units, equipment, and supplies. The robots now take on their second life roles to aid the next phase. They come together to make flexible mobile platforms that can carry the payload from the loading zone to the base. The convoy begins its journey across the Martian surface to the habitat site. The build commences with a connector module placed underneath the protective shield and ready for inflation. The module then unfolds and self-inflates into its final form. The habitation units are then placed into position and sequentially inflated to form the completed pressurized environments. The circular layout of the habitat ensures continuous accessibility of the habitat in the event of a catastrophic failure. Each connector module houses 3 integrated environmental control life support systems, delivering essential services like power, water, data, and oxygen to all the habitation units. A circular conduit delivers these services to multiple endpoints in each pod. The base will be remotely powered by 2 nuclear kilopower reactors and a solar farm, located a safe distance away from the base. In the next stage, the astronauts will construct and install a flat-pack, rail-based racking system capable of connecting to the distribution system, enabling spaces to reconfigure according to their spatial needs. This modular and radical design principle has been adopted for all the habitat pods, ensuring multi-use, reconfigurable environments. A Martian base should not just be a habitat. It is home for the astronauts. Each pod expresses its own identity, quality, and character. A highly functional design which places the human experience at the core. Spaces include a state-of-the-art research laboratory, a hydroponic greenhouse, a fully equipped workshop with digital fabrication facilities, the sleeping quarters with gym facilities, and immersive virtual reality platform. We believe that the key to success of human habitation on Mars is the health and well-being of its residents. Creating a place where work, life, and living combine holistically to ensure they feel connected to each other, to themselves, and somehow to their distant home.
You're back, Josh.
Okay, perfect. Well, look, I'll jump straight into it. Hopefully everyone was able to have a watch of that and our 5-minute film working in conjunction with Xavier. And it's sort of, again, an incredible project to be involved in. And hopefully, I say, we can take you through a little bit more about sort of what we've done and how we made all of those ideas come together. So myself, I'm Clark Denman, one of the founders and art directors at Lightflied London. And tonight I have also with me a fellow co-founder and art director, James Lehman as well, who will talk you through a little bit more of the technical aspects of the project a little bit later. So a little bit about sort of Lightflied. Let's just jump into presentation, always does help. Okay. So myself, Clark and James, so you know who we are, all done. And then, so we've got, Lightflied London, we've kind of formed of initially 4 guys. We have now grown to a team of 14, but from the original 4, we were all based out in Foster & Partners, where we ended up kind of working sort of for a number of years, learning many, many things there. For those that don't know what Foster & Partners is, it's an incredible architecture firm, home of one of the greatest living architects, Lord Norman Foster, I should say. Built things like the Gherkin, who obviously many of you will know that iconic nature of that building. We kind of were there as a team of 25 at the time. exposed to many sort of iconic things around the world, infrastructure, technology. We learned our skills and our trade, but after a little bit of time decided that we'd go and take the leap, and we've set up Lightfield. So yeah, just under 3 years old at the minute, and growing rapidly. Again, we still take on a lot of information in the architecture world, heavily involved in that, and kind of continue to be exposed to a lot more industries, applying all the skill sets that we've built up over the time, expanding the studio in many things. So I think the easiest way for me to show that to everybody is just to jump back into another video and show everybody the showreel. Okay, so yeah, hopefully everyone could see that and hear that. So just again, look, it's a fantastic way to showcase what we are doing here at Lightfield. So we're very mixed discipline sort of studio, and say a whole variety of things. Let me just hop back to my presentation. Share. So as you can see, we're doing a lot of 3D animation. I mean, look, we love that stuff. We can't get enough of it. We're sort of working through, say, using a whole host of programs. We're using Cinema 4D, 3D Studio Max. We're still using Octane, using Corona as well, a lot. But also, say, the stuff that you can't communicate in the showreel, we're doing a lot of ideation. So we really love engaging with our clients. I mean, it's such a pain at the minute. I know the world is a complicated place, but back in the day, when you could have everyone in the room, the magnetic wall, you're kind of using that to the full advantage, engaging with people as much as possible, just to kind of make sure that the idea is resolved and solved at a very early stage of the project, and helping to identify kind of new ways of thinking, merging our ideas. Again, with our backgrounds, we've been incredibly fortunate to kind of be exposed to so many different sort of industries and technologies that sort of when our sort of ideas kind of merge, we begin to create some very interesting stuff. We're also, say, graphic design. That's one of my backgrounds. Have a lovely lady, a part of our team, Aurora. She's kind of helping us out with that. We're expanding all of that side of things as well. Again, the motion graphic side, everything begins to fuel into one another. Again, we have an incredible team. So we have a couple of guys that are absolutely making some amazing content. Again, NDAs is an absolute pain where can't show you everything we're working on, but say we work to a very, very high standard. And again, like once we kind of get these locked down, we're helping make those move, and we're kind of, yeah, again, making just very, very beautiful things and bringing lots of things to life all across the world. Also kind of working on product renders. Again, just lovely to get involved with those details, working into stuff, bringing all of that stuff to life with the product renders. As Xavier briefly touched on as well, we have an Unreal department as well. We are sort of getting fully involved with that, and had, say, through Xavier, very, very lucky to be able to create content for the Design Museum. Again, making just kind of a different sort of use of our skill sets and how we can begin to bring that all together. Also, say when budgets allow, we do scale up to big screen, green screen productions, I should say, where we kind of say fully involved. So we have done sort of a mixture of broadcast design as well. Obviously, tracking if there's drone footage, helicopter footage, linking more into our sort of architectural background, but we can also kind of go up to that sort of level of detail. So the compositing, cleaning up, we make sure all of that is taken care of. And then more sort of recently, virtual production, we're pushing that. We really sort of love being involved with that. So we're really starting to ramp up in that area as well. Obviously, I say, I'm sure a lot of you are kind of familiar with that technology, but we think that it's an absolute game changer for the industry. So we're using our Unreal technology to drive a lot of that as well. And not forgetting, again, hopefully you heard the music on the show reel, is that we have an amazing composer, Jack Goodenday, I say another founder, who is just an incredible talent and sort of helps just bring a whole nother meaning to life. So for certain projects, we will go and get an orchestra with the music that he's composed. We'll have that played and recorded, and it just adds a whole nother level to our production qualities. But say that's enough about Lightfield, and so moving on to the main Mars film now. So the brief. So Xavier approached us. Basically, I need to make a 5-minute long film of this really complicated problem. So the feasibility of living in a habitation unit on Mars. It's like, okay, all right. So where do we start? So normally with a project like this, timescales 6 to 12 weeks. That's a good range for us to work with. Obviously, we have all of the stuff that we need to get to, the research, the narrative, the storyboarding, kind of that initial sort of pre-production side of thing, going all the way into the production, where we need to look at kind of the animatic work, the look there, the motion design, graphics, animation, all of that sort of level of thinking, and then allow yourself enough time to render that old chestnut. So again, with compositing, grading, all happening in the last time. The way this one worked out, we only had 3 weeks. So as you can sort of visually see, everything gets somewhat compressed. It kind of makes things, you know, exciting, I think is the word. But we have to be very, very organized. It's, so it's not impossible, as we've kind of proved. So yeah, everything that you had seen was completed inside 3 weeks. And I know I have shown this on a July to August slide, but it was done with Christmas Day bang smack in the middle of it. So yeah, there was rendering in Turkey that year. So how did we make that happen? We had 4 3D artists. We had a scriptwriter, who again, just a massive crucial part, and I'll talk about that in a minute. And we have an editor and composer, obviously, to hand. So editing happening all at the same time as the music, sound effects, everything being thought about, just where everything's completely consolidated. So pre-production. Xavier kind of, again, a couple of meetings over at the HASSELL studios, and with his team, took us through all of their thinking. So I know he's skimmed the surface, and he's done an incredible job at doing that tonight. But there was, you know, reels and reels and reels of information. Now, my background's animation. I'm no NASA scientist or anything, but all of a sudden we left this process feeling like, you know, I'm there. I could go and fly a rocket, kind of thing. It's so there's so much that we had to get through just to kind of make sure that we are communicating. That was the key thing with this project. It really had to sell it back to NASA that what Xavier was thinking was the right option. So we really had to make sure that we hit so many key points, but all within this 5-minute time frame. So in addition to that, so we've got the research happening, we're becoming scientific advisors, but at the same time, we still want to be artists. So we're still looking at images that inspire us, mood boards, we're having a look at all of that creative stuff. It's all got to happen in parallel. We also then kind of have our scriptwriter. So I have an incredible guy that then sort of we sort of almost brain dump onto him. We tell him everything, we show him all the visuals. So he gets a consolidated version of what Xavier's gone through with us. He will then go away and begin to kind of develop what he sees as a story. Now, he has a great background in sort of broadcast, dealing with timescales, so very good, very efficient at helping consolidate it down into those key messages. And I think you'll agree, obviously, having now seen the film, that that nicely kind of ticks along. So once we've got that, we start storyboarding. So normally in our 6 to 12 week timeline, we'd like to have something where the storyboard kind of more worked up. Here's a couple of frames from some other projects that we've done, but you know, the storyboard is a thing of beauty normally, where it will be pinned up on the wall. We will push and pull things around and kind of interact and just make sure that it's resolved on paper first. Obviously, that's the cheapest bit of production before we get into any 3D, before we start doing any look dev. Let's get that solved. However, because of the time constraints, it ended up looking like this. We had to jump straight into the 3D. Now, look, there's nothing wrong with that. It's just kind of, say, not necessarily the ideal way of working. It's kind of, you're kind of beginning to start to commit to space, the movement, compositions without knowing it. It's kind of a funny sort of thing. So we just kind of, with early prototype models, so there's a lot of duplication of model import as well. This is another reason why it's not kind of good. Xavier was still designing, still tweaking. Again, I know he touched on sort of the modular nature of the robots. A lot of that was kind of happening. It's kind of, again, just an example that here we're kind of beginning to refine the storyboard a little bit more with HASSELL. So we go through, I think this is version 6, 5 of the storyboard, many iterations. So all of this is still happening, the script's getting developed, everything kind of working around that 5-minute timeline, and all the time the clock is ticking and we need to get sort of animating and rendering. So yeah, we kind of, you know, ends up sort of being that first week of just, right, just get something out on paper, as it were, or in your 3D scene. So pipeline tools, again, how do we make this all happen? So we use something called Shotgun. I imagine some of you people that are in the film industry will know all about this. Now, sort of Lightfield, we don't use this at its full capacity. I mean, look, at the time as well, we were only a small studio, swivel around in your chair, speak to the man next to you. However, it is great for us to communicate not only with our editor, but just keep an eye on the progress of all the different shots. As you can see, there was a lot of shots in that film. It's the only way to make a long film, just include more shots, keep it visually engaging, and kind of get through that. So we can log all the status, shot numbers, just coordinate all of our Cinema 4D files. Again, where we were working over that Christmas sort of holiday period, we could keep everyone up to date, remote working like we're kind of doing now, I suppose. Again, with Shotgun, you have a review tool. It's very nice to be able to kind of work with that, engage with people, with the client, make sure everything's commented on, make sure we can understand what one another's thinking, start marking up additional little comments as the first few frames come out. We then worked with HASSELL with their Bluescape screen, which was an amazing bit of kit. Just lovely to kind of see how that's all kind of churning away. See all of the updates on the project as well, and how that's kind of evolving. So again, this very sort of fluid process where they were just thinking, they were having design reviews as we're trying to animate. So, you know, an animator's nightmare that as fast as you're kind of getting through something, oh guys, we changed it. But look, we're very used to that. It used to happen to us all the time at Foster's, highly skilled and highly adaptive to that kind of scenario. So working with proxies, all of that sort of thing, which I know James will speak about soon. So yeah, talking of James, production begins. So I will hand over to James now, who will talk you through that in a little bit more detail. Over to you, James.
Great, thank you, Clark. So I'm just going to talk about a bit more of the more technical breakdown of how we managed to achieve the project. As Clark was saying, the models were being designed by HASSELL of the robots and the habitats. I think they were designing these in Rhino. So one of the big things we had to quickly do was make sure that we could import these models from Rhino into C4D, which was what we were using for this project, very quickly, flexible, so that if there were changes as they were designing new robots, this wasn't a massive headache for us to update the models. As I said, we use Cinema 4D, especially for this project. Cinema 4D is predominantly known for motion graphics, stuff like titles, etc. But over the years, the software has developed to be more mainstream, very versatile, and very robust. And it was very well integrated into our pipeline, and all the artists that we had available were proficient in the software. To go along with Cinema 4D, we used Octane, which is a GPU rendering. It's unbiased, which means it doesn't cheat at calculating lighting and reflections. So it's kind of what you see is what you get. This means that it's very quick to set up, and also the rendering speed can be very, very quick because it's using GPU cores. Here you can just see a bit of the Octane renderer in our live viewer. So once we've created this scene in Octane, applied shaders and lighting, you can quite quickly tumble around the scene very quickly. I mean, this was just recorded on my laptop at home, which has just got a Razer with a single GPU. So you can imagine when we in the office with our water-cooled multiple GPU machines, it's like almost like real time. So this was like ideal for this deadline, as we only had 3 weeks. We needed to be able to render very quickly. So one of the biggest things is what's the film going to look like in terms of style? I mean, we wanted to go with something fairly photorealistic for a large portion of the film. Obviously, we weren't going to get to film quality, but we looked at a lot of films as references, like The Martian and etc. Looked at a lot of Pinterest and mood boards. Obviously, we couldn't do a site visit at that time because the weather wasn't very good on Mars. So here you can see we just did some material and shader tests using, I believe it was RD textures, which were really good PBR materials, and we kind of modified them to make them look very Martian landscaping, comparing that also with NASA images that we had access to. The next step was to create a scene, a set where we could place a lot of our robots and habitat into. So we then looked at creating a terrain. I believe we used World Creator to generate the actual landscape, and then imported that in. As you can see, I don't know if you know that there actually used to be water on Mars. Therefore, you have to see like runoffs of the mountains, etc. So we wanted to get that kind of detail in. So we created these shaders like atmosphere, using scanned assets like rocks, but also creating detailed foregrounds so that we could place our habitat, etc., and still have good detail in the ground. The next step was to look at the design language for the actual robots themselves. Again, we looked at lots of NASA latest robots, film. I know Xavier was saying about we didn't want to make it look too futuristic. Almost wanted it to look like as if Apple would design a robot. So we took, I think the first robot that we had access to was this Scouter robot. So we started looking at that. I think we did about 50 different options for the colors and how it might look, and adding details into the wheel, like the dust almost sitting on top of the suspension arms, etc. So, and also wear and tear. So once we had a design that was approved, we were able to then start rolling that out onto all the other robots as they were being modeled. Here you can see a few more concept frames from once we had like the terrain, we had some of the models, we could start setting some of the scenes of what they might look like. There's a few more. I don't think any of these actually made the film, but you can see they're just kind of concept frames. And it was like how would the robots and convoys fit into the environment using depth of field and etc. to make it look beautiful. One of the other challenges was that even though it needed to show technical details, but explained elements in a very easy to use, easy to understand way. Although this was actually going for NASA, it still needed to target a wider audience of people. For instance, would your mum understand what's going on? And we actually felt that by putting this actually in the landscape terrain, it started to get quite busy and distracting. Therefore, we simplified the background and tinted back the sort of Martian landscape into the black, just to give it a really stylistic approach, which hopefully looks nice and clear. Okay, animation. As Clark mentioned, we blocked out the kind of storyboard straight away, almost in 3D, which then allowed us to start creating basic animatics, either using blocks or the models that we had so far. So by doing this, we could block out our edit fairly quickly within days. I think some of these snippets that you can see here are probably more advanced, but some of them are just very low level. So once we did that, we would then keep refining into each of the animations to add more detail and get it right. There were some more technical challenges though of the animation in this film that we wanted to achieve. One of the first one was inflation of the pods. We looked at robot rigging, dust and fumes, terrain displacement, and the time-lapse animation. Okay, one of the most challenging things of this project, probably for myself, was the actual inflation of the pods. I had many sleepless nights of how to do this, and my knowledge of Houdini is very minimal, to be honest. When I started opening up and playing with cloth and sims, and thought, yeah, I think I'm going to fail at this. So I quickly went back to Cinema 4D and started scratching my head, and then finally managed to find a workflow that worked for me. the technique I kind of used was to build a low poly version of the habitat dome, the fabric material, and did a cloth simulation, but did the cloth simulation in reverse, so it actually deflates and then folds away. I found this easier to actually calculate and sim. Once we calculated that, I could reverse the bait animation and then attach that to the high poly mesh that was given to us by HASSELL. So yeah, that was quite a headache, but I think you can see it kind of worked for the purposes of what we needed it to do. The other thing, we wanted these robots to drive around the terrain. They had to maneuver in certain positions, etc. And to avoid having to keyframe all the like wheel rotations and height and hydraulics, we basically took a car rig and then adapted the code so that once the robot could then be a single-wheeled robot and drive along the spline, have suspension, could go over terrain, etc. And then once we had this rig, we could apply this to all the animations. We did have a slightly different rig for when all the robots came together into a swarm. Another animation challenge was to get sort of realistic dust and fumes to really make this look convincing and have a high quality look to it. So we used two plugins, Turbulence FD and X Particles C4D, to generate the dust and rocket fumes. Both have fluid dynamics. We then rendered these sims out as separate passes and then comped them in. Here you can see the dust coming off the wheels of a convoy. We just attached particle emitters to the wheels, and hey presto, there you go, lovely dust smoke. Even though our timeline for this project was super tight, we didn't want to stop at not adding fine little details that we wanted to get into the film. So as you can see behind the wheel, the displacement of the wheel is pushing down the terrain. We actually then put another layer of terrain below this, so that as the collision of the wheel goes over, it pushes the geometry down and reveals the second or lighter coloured sand underneath. As Xavier mentioned about the time lapse, I think this building would take several years to build. Sorry, a habitat would take the robots several years to 3D print. Therefore, we wouldn't have several years in our film, so we time-lapsed this element to give that effect. We did this by using an animated Boolean and then rigged the robots so that they actually kind of sat on top of the animated Boolean. I think we did this over thousands of frames, and then what we did was rendered every 25 frames to give a nice sort of time-lapse effect. Cameras. So whilst we had kind of mapped out in our storyboard and animatics what cameras we originally thought, with the power of Octane, once we developed our scenes, because they were so quick, it's almost like once we developed, looked at the scene, you could almost get a camera and move around the scene and find new cameras. So we did this, and you can see other cameras sort of developed out of this just to enhance the film. Rendering. So the only drawback with using GPU rendering, obviously the speed, but when you do start to put large amounts of geometry and textures into the GPUs, it does start to slow down and also become slightly buggy. Therefore, what we used was creating proxies and low poly meshes for robots in the distance and multiple clones. So we were quite good at optimizing our scenes to allow us to carry on getting creative and getting the project through the deadline. To render it, because we were using GPU rendering, we had, at the time, we had around 26 GPU cards, all 1080 Ti's, and we also used remote servers which had 16 GPU cards. And for the 1080p film, we were kind of averaging around 30 seconds a frame for the exterior views, and around 3 to 4 minutes a frame for some of the more heavier interior scenes. So as you can see, kind of 30 seconds a frame is to fare quite quick. So therefore, we managed to get through the 5-minute film and still be able to render a couple of the shots several times for amends and finessing. Again, because we used Octane, what you see is almost like what you get. We didn't have to render lots of passes, and therefore there wasn't much time needed for comp work. I think the only comp we had to do was sort of comping in the dust and effects work, which again made sure that we got through to the deadline. Okay, I'm now going to pass you back over to Clark, who's going to just talk about the rest of the project.
Thank you for that, James. I say I'm kind of aware of time, but I will whiz through this last little bit. So while all that's been going on, the script has been evolving. There's still been changes. Xavier's been dealing with our fellow co-founder, creative director Johnny Cox, who is sort of heading the edit at the time. So he's seeing all the stuff that we're publishing to Shotgun. There's a whole load of kind of adjustments in the wording, the language. No, we must kind of mention about this. The front sort of 1 minute of the film, the diagrammatical piece was bouncing around left, right and center, just trying to make sure that it was clear and concise. The visuals for that were changing. We needed to make sure that it was easy to understand as well, just for sort of all people involved. So yeah, we'd use Premiere, obviously bread and butter for editing, absolutely great. There's versions of the voiceover coming in. We're having to spice that up. I mean, in the final submission, there was a reason why the credits were only a second long. It was like NASA have got a pause button, they can use it. We're kind of, we won't worry about that. We just need the time to get the story in, get those key points, get that key messaging in. So everything's moving around. And as I say, sound. Now, we have that amazing composer in-house, and it just changes the game. I mean, we have had some projects where we've put our audience, our clients in tears, just with that emotional reaction. And they say it's kind of 50% of the connection from the video to the audio. I think at times, actually, it's a lot more than that, because it just has a complete power to be bespoke, to pick up on certain things, to trail it across. But so also with that, it's the voiceover as well. Again, the big decisions. I've got, I think, so used to watching it with that voice, it just works. But we went through different options. Should it be male? Should it be female? Should they be American or not? It's kind of like it's for NASA at the same time. All of these little considerations that we really kind of had to pore over, test things out, try it. As a rule of thumb as well, we always tend to get 2 different options of the voiceovers recorded, just in case the client, change of mind. In any of sort of our other projects, it's always sort of handy to have. So good to have. And as I mentioned, here's Jack at his desk. Sort of, he uses Apple Logic Pro. He just kind of in the zone. So the showreel piece of music, for example, that you heard, I do believe he wrote that in about 6 hours. How he did that, no idea. But is just a phenomenal talent, but it just brings a whole different dynamic to our whole film and the collective. So as Jane mentioned, with the ability of Octane and the rapidness of just rapid prototyping, moving the camera around, the flexibility of the music, we can come together and really create something quite impressive, just like this view. So bizarrely, this was deadline day. This was from our office. So not only were we working on the red planet, we had this amazing red sunset outside, but so our office here located in Vauxhall on the banks of the River Thames. Those that don't know London too well, just down the road from Big Ben. So bang smack in the centre of things. We love it. Fantastic place to be. But as I was putting this photo in, actually, well, the proof is in the pudding, right? So what you can see here on the screens is red arrow, we've got shotguns being used. That's happening. Green arrow, cinema 4Ds being worked on. We've got Jack, a bit of music, although he's actually a very talented C4D artist, who knew, happening at the same time. Got the blue arrow, the premiere timeline is happening, pumped into the big TV, constantly being reviewed, checking out all the frames. And just out of screen, James is still trying to inflate his polygons. So yeah, that went down to the wire with that shot. But yeah, fun times we had. And just then to say that once the film was finally released to the public, we had 22 million views in the various sort of platforms. It just completely took off. I mean, there'd been sort of a challenge, an unwritten challenge with Xavier was like, it'd be nice to get 1 million, you know, and we're thinking, that's good, but it just absolutely flew. Obviously, hopefully many of you are watching, but a fascination about space and travel, and just kind of I think it's you know, there's something there for everybody. And we had, you know, some lovely messages from, I think it was the best one was a teacher out in the States. I've just shown my little class of kids like your video. Round of applause was had at the end. Just absolutely loved it, and it's nice that we have that ability to connect. And also nice, it earned Lightflied London its first staff Vimeo pick as well, so that was, you know, a little proud moment for us as well. Again, it's sort of just such a great project to be involved in, and we thank Xavier so much for involving us in that. And just look, I want to say thank you to 3ds Meetups. It's lovely to go kind of back. I used to attend many years ago until I got really busy. And actually, it's how I got my job at Foster & Partners. So maybe in some ways I've gone full circle, but you know, there we go. I would also just like to say, look, we have an amazing team of artists at the minute, but we're always looking for more people to join us. So whatever you do, whatever you're kind of creating, making, whether your background's in Unreal, Houdini, like, I want to know, speak to me, graphics. Like, we are growing rapidly. So if that inspires you, I say we're doing plenty of other things. Come and get in touch. Say we're looking to relocate to a nice safe office, and hopefully we can get back on track once the world kind of gets back to normality and we get up and running. All right, but look, that's from me, just to say thank you to everybody, and I'll hand back to the team. Hope you've enjoyed that.
Amazing stuff. Thank you so much. Yeah, I think we're all very impressed. Thank you, Clark, and thank you, James. I mean, the film is amazing, and your show reel is amazing as well. Great to see so much passion and yeah, and so much amazing work as well.
Yeah, fantastic. Thanks, Clark. Thanks, James. Really superb. Really,
I love that team as well. I think that, you know, music is often underestimated. I mean, you said this yourself. You know, I think yeah, a lot of people don't realize the impact that music and Foley can have on stuff. And 3 weeks over Christmas as well. Are you kidding me? This is nuts.
I'd say as James is going through that, I'm kind of like, we did do that, right? Just I mean, the technical challenges.
Then we can continue that conversation.
It's, no, for not. I mean,
I see Xavier smiling away.
He had the other 9 weeks, right? Let's just, you know, it's like. Yeah.
I mean, your render times are really fast as well, though, aren't you? You're talking.
It's changed everything. It's obviously the cards. I mean, we were running the 1080s then. We're now kind of more or less all 2080s and starting to get the 3090s, whatever they are. It's kind of like. It's just changing our ability, and I'm sure all sort of 3D artists, you know, you go from just, oh, this is interesting, and I can look at that, and I think even the shot and the visor, we're looking at the reflection, but it's stuff like that that, you know, back in the day you kind of wouldn't have been able to find and go and explore the scene. You think and you tell the story differently. It just, you're not having to do the comp, you're not having to do all of that side of things, so you get more time in production to experiment, and that's what we enjoy, right? We're artists. That's what you want to do. It's kind of look for the nice things. The team will all get, we deliberately shape our office like a shoehorn, so a horseshoe, I should say. But it just so we can spin around, look at one another's screens, and just get excited by the renders, right? Look, it's our hobbies as well. It's kind of what we enjoy doing. So that passion comes out when a project like this turns up. It is once in I say blue moon, but maybe red planet. It's kind of like, you can really go for it and get excited about it. So no, we do.
Well, it was obvious that there was a lot of passion behind the project. It was really fantastic. So I scribbled 2 notes down, and neither of them are very sensible. But the first note I wrote down was, I like your robots. They're very good, but I preferred the one in Terrahawks. I like the ball bearings in Terrahawks that lived on Mars. They had a bit more.
Speak to Xavier about that. That's it.
And the other thing you just touched on it, but the idea of GPU rendering, and in fact, what I was going to ask you is, how would you did you guys consider doing this in Unreal, for example?
Look, I think that potentially is the future. Due to skill sets at the time, we didn't have that as a viable option. But going forwards, I mean, say the film's a couple of years old now. I mean, what has developed in Unreal is, it is game changing, right? There's no 2 words about it. It's kind of, it really, if we were to do it again, it would be high up on the list for consideration. And certainly the way we're seeing our business grow with the virtual production and that use of the technology, again, we would treat it in a very, very different light. That's for sure.
I think also, just to jump onto that as well, is that the exhibition that we did later on for the Design Museum was actually done in Unreal, so we almost like mimicked some of the scenes that we did in Octane and Cinema 4D in Unreal. So yes, to your question. But
And lastly, I know there's a little pop at you there, James, about your inflating polygons, but I just wanted to say that was incredible. Really, really.
No, he is an incredible.
So well done. It was worth all the hassle it must have been.
Yeah, I wasn't going to be beaten on that one, but it was times where I was scratching my head, so how am I going to do this?
And it was, James, it was also kind of like a crucial part of design. It was something that, we wanted to explain how it was done, the inflation. So yeah, it was amazing. Also, guys, I think the great thing was, I think the collaboration is that because we all knew each other, because we've worked all together before at Foster, so we kind of knew how to kind of get this done in communication wise. I kind of knew what the guys could deliver. They were often telling me what could change and what couldn't change anymore. I think that was really important. I kind of understood the technicalities of it, that's still, you can move that or you can't do that, and that was actually continuously talking about that. That was super important.
I know my clients appreciate that.
Yeah, I don't. So I don't really have clients. I have fellow architects, probably the same as you, Xavier. But I just say, oh no, we can't do that. Not now. That's far too late. It's much easier to say that. It works really well.
We try and be as flexible as possible. We always will be. But no, at times it's kind of like if you've got half an hour to the deadline, we'd be sensible.
So when I spoke with Johnny Cox, he said that the film was picked up and re-edited by other people as well.
So a lot of big fan base out there, right, Xavier? I mean, Xavier probably knows more about that, but look, we see it as a great honor, right, that people want to do that. And
it was kind of picked up. We brought it out, and we had some good views, and I think we didn't really get the views that I wanted. So we then started to kind of promote a little bit, and I pushed it towards some Instagram posts. And at some point, I think it was on a Saturday, our YouTube video just jumped up with hundreds and thousands of views. And I was like, what happened? What happened? And what apparently happened, it was picked up on Reddit, and people start talking about it. And it was upvoted 25,000 times in like a week or something, only like a couple of days or something like that. And then it kind of just snowballed from there, and it keeps on snowballing. People have re-edited it. quite interestingly, for in a square format on mobile, made a shorter version, made all sorts of things. And I was really annoyed by that because we had it so nicely done. But then I learned the thing, and I was like, and then I saw like 18 million views on Facebook or something. I was like, oh, okay, I don't mind that much anymore. It's fine. But it was good to see that.
I'm a serious Redditor, so I think the Reddit hug of death is an honour. So I think you did well there.
I've spent the last week on Game Shop. Yeah, okay, fantastic, guys. Unless there's any other questions, I think we're good to move on. I'd just love to thank Xavier and James and Clark for some awesome presentations.
Yes, thank you, guys. It was absolutely fantastic.
Thank you for having us.
Thank you so much.
Yeah, great to have you on board. And now we're going to move into our final presentation for the evening, and it's my pleasure to introduce Wayne Robson to talk about his work with Screen Scene, working as were you 3D lead or 3D super?
I was 3D supervisor on that, yeah.
Yeah, fantastic. You're normally a character artist, though, aren't you, Wayne?
I've done all sorts, to be honest. After 25 years plus, it's easy to say what I haven't done. But yeah, I've done all sorts. I've been lead lighting artist. I've worked in games. All sorts. So
I'm going to jump in quickly here. So very excited to see Wayne here. He the last time he came down to London we reckon, Wayne, it was about 10 years ago. So
it's got to be around 2010, I'm betting.
Yeah, so good to have you back. And we were also, as the 3ds London committee, we were also slightly nervous about inviting Wayne on here. not because he's a wild cannon, but
well, that as well.
Xavier and the guys, your presentation was so good and it was so well thought out. And then Wayne is definitely going to cover the more violent side of Mars exploration. So we were slightly nervous that it would jar, but I think it's going to work out really well.
I think Wayne's presentation is going to be a little bit less about science fact, hopefully.
I think it's going to be more about blood splatter. Yeah.
Yes, that, and yes, you'd be surprised how much science there was behind it. Right? Yeah. Do you want to share the reel with the sound off that side or this side?
Yeah, Nigel, please.
I can do that. Hang on.
Yeah, just make sure it's mute the sound, otherwise YouTube will pig fit.
There's no sound on the clip. We had to censor Wayne's music selection. So Wayne, if you want to start talking while the thing's going, then that's great.
Cool. Yes. So if you're a leader or a supervisor, that's what you do, is you give it to them. Now I will share my screen and we will try and work this all out. First of all, let's just start with the rover and I will share that there. Right, can everybody see the rover? I hope so. Right, so this is the model itself. Now, I would not have been able to do this back in 2012 or 2013. We were using Max 2009. And if you wanted to get that rover using this null from there to over here, you were looking at half an hour. Because you're looking at over 5 million polys. There are thousands of parts on here, even right inside the cab as well. This was all modeled and textured by Daniel Rath. He'd started before I had on this. We had some amazing controls. It had to be scripted. And John O'Connell, who's now working at ILM, by the way, who's my number 2, created a wonderful system. Now, this is the basic version because it ran off scripts. So I can, you can move the wheels, you can take the main bit there and fiddle with the cab and all that. Everything moves, everything responds to everything else in a mechanical way. And some of the detail on it, just in poly mode, because half the textures after 8 years were bye-byes into the ether, is quite amazing what you managed to do, Daniel Rath, in a short length of time. And especially when you've got the likes of Glenn Southern on the team, who everybody knows is a fantastic poly modeler going way back. If your poly work is not good, Glenn's going to say something. And Daniel, at the time, was very early on in his career, and he really pulled it out of the hat. One problem we did have, which was a design issue, which we couldn't solve, and that is the wheels here. They went and had it properly designed, then got a hold of it, and they came to the conclusion that on Mars, this was the best sort of tread. Unfortunately, as you'll notice on that shot 1016, when motion blur is active and these wheels are rotating, right, you can't see what speed it's going because the tracks are too small. It was one of those things we couldn't solve. We tried everything, and that's one of the reasons why shot 1016 took as long as it did. Everything on this, right away down to tiny little bolts in holes like that, right, has an 8K map. This was not my idea. However, it also made it a pain in the backside to render. We were going through deadline, and early on we had some amazing bugs. Like one day we submitted 5 shots just as tests because they weren't final, we didn't have the logos approved yet. And it turned out Barbie pink. Everything was Barbie pink, and we didn't know why. And we tracked it down. It was down to a lot of, there was that many layered 8K maps on top of each other. We need to optimize it. Now, what I did is I took one look at this, and I realized there was 3 classifications of shot. There was the ones that were fairly close up, like 1016. There were the ones that were very far away, like 1011. And you did not need, in any universe, 8K maps on a bolt when the entire rover was maybe 25 pixels tall. So I said, well, okay, why don't we just use a level of detail on the texture, which people in the team hadn't really came across too much because they were visual effects artists, not games artists. So I asked John O'Connell to write a script. And what it would do is, if the rover was that sort of distance, it would then load a 1K map set. If it was that sort of distance, it would load a 2K map set. And then, based on camera distance to one of these nodes, I think it was that one. So it automatically did that, depending on what shot, how far away it was, and things like that. Now, lighting this is where we sort of broke all the rules, because normally when you're lighting stuff like this, there's lots of reflectors and multiple lights and blah, 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 blah. All the outdoor shots are lit using a single light and bounce light. That's all it is. While there were HDRs for a lot of the scenes, there was some that had none. So I'll tell you what my logic was. This is Mars. Although it looks quite nice, it looks rather the same. It was filmed, by the way, in Wadi Rum and Jordan, where they filmed some of the latest Star Wars movies and The Martian and stuff. It's basically red dust, right, with blue sky. So what we would do is nick one of the HDRs from one of the other shots. I would send it down to comp and say, right, take the sun out of that shot. They take the sun out. We would then put it in the shot, roughly align it, stick the sun in, make sure it was lit correctly for the shot. Boom, sorted. And we had quite a fast turnover. To be honest, if, you know, I'd been able to move the rover as fast as I can now, you know, in Max nowadays, the entire sort of film would have been done in about 3 weeks. We were juggling 6 machines at a time each at one point. So I will change over to a different scene file. Let's just see if I can stop sharing that for a second. Well, I load another one while I'm doing this one, because it's that one, right? So don't want to save over the top of that. That's the original one. And we'll share the next one, which should be this one, the zombie. Now, at some point, these eyes are going to turn blue because, funny story, just after Christmas, my really good graphics card exploded in a shower of sparks. So I'm stuck with a really old, rubbishy one, and it can't handle all the textures. This is an 8K texture on here of the zombie head that was done in my free time. In fact, before this happens, I'm just going to get rid of that, because if I don't, they'll have blue eyes. It looks quite scary. So this went through a lot of research. There was concept art that was provided. And Roy Robson, the director, being a 3D artist, he took this idea of a zombie very seriously. What would a zombie look like on Mars? Most of the decay that you see that modern zombies are based on is what I would call wet decomposition, because we have a lot of liquid in the soil and things like this. So it decomposes in a different way. On Mars, it would not only be dry, but incredibly cold. This made it a pain to find reference for. But we did find some, and the reference photo that I had was like a horror show at one point. I had to get a special dispensation in a hole through the firewall. It was quite funny in a way. Now, this is obviously separate parts. So if I just hide, you know, that there, and we go back to the face, which has now went blue, and I'll just up arrow so we can see the textures, and then I will turn this off. And these are all the textures here. That's this there. Let's just see if I can get it to convince it to show me things. Lovely. Right, take the bump map off. And there's about, in the whole thing, about 6.5 million polys. It wasn't really going mad. The low res is extremely low res. In fact, what I used was the level 1, because if I go down to 0, it disappears in Mudbox. We never did work out why. So if I go into flat shading mode and put the wireframe on, it's not that high, but bearing in mind what this guy is doing a lot of the time is screaming at people and going with his mouth and looking angry. You didn't need a lot of control. There was no point overthinking it. So for this, there was, and let me just consult my notes here. I'll tell you exactly how. There was only 19 blend shapes on the entire character. Now, the bone rig was very, very simple. And most of the stuff that you see was stuff in the eyes. In fact, I'll try and, if it behaves itself, I'll show you the sort of thing I would do. Is when I was doing the blend shapes, I would make a layer at this level. I would then go along and find my freeze brush and bring it up like this. Just, you know, just isolate off an area like that. Then go along, get the grab brush, make sure it's not too angry, because normally I set it around 50. And then you could, you know, bring it down, make sure the folds are right, and obviously take a little bit more time than I'm doing here. But so once you've got that, unfreeze it. And if I stick it back onto smooth shade mode, obviously I can then fade this in and out. So that was what a lot of the blend shapes were. It wasn't based on the FACS system. It was sort of a hybrid, sort of a zombie hybrid of the FACS system for facial animation. So that was basically the zombie. The texture was all hand textured. And it was a case of what happens to human skin when it gets very dry and cold, which gave me some tremendous nightmares, some of those reference images, you know. But there's quite a lot of detail in it. That was a mask that we used for certain blend shapes so that it would show transparency. It's really like a marble type effect, what happens, and it would go green. And it had to be based, obviously, on the original actor's face, because we already had a digital double of him, as it happened. So I used that as a basis, ripped the face off the model, and used that as the basis to sculpt everything else, and work out how the muscle would dry, where it would pull in, you know, places like this, where it would affect the bone as well, because it would be that cold that it could cause problems on that level if you were a human being. Right, now if I go to my other one, I'm just going to open another one of these because I've got a system here where I can, right, save that one. This one should be loaded now, and off we go. So, it's been quite a while since I've had to do stuff like this, you know. Right, that should be it. Has it loaded the correct one? Or is it still loading? Oh, there we go. Yes, this is getting there. Right, I can share it now. Right. I'll go to flat color. Just hide a few of the lights and stuff like that because it's very distracting. And we don't need the cameras. This was the final version, which was in a turntable. So obviously we've got a lot of helpers here. So there's two helpers that are parented to this over here, which we worked out was the optimum distance for moving the eyes, so the eyes would rotate and not look cross-eyed. If you get too close to it, things can, you know, look a bit odd, and it looks like somebody's looking at the nose. There's basically two bones in this, like one going down there and one going down the neck. There's a small one for the jaw in here, if I can actually find it. It's been 8 years since I looked at this, so that's quite a long time with my amazing naming system. If I go to the main head here, and we'll show you, this is the morph targets there. So the best one was the one that took the longest to do, which was this one that does this for the mouth. Normally that would animate the teeth as well and pull them back. And that, if you're trying to do that in any sculpting application and get it to slide laterally without going in or out, it's really not easy. That took, you know, an entire night of many attempts to get that one movement correct on that. The zombie itself, it held up well enough in the film. The first shot in the reel is the very first version I saw of it, because that stuff was all rendered out by Rory himself, and he composited in After Effects, whereas the rest of the film was in Nuke. And he had a very old school way of lighting. So with him, there was a million lights in different color codes like red, green, and blue. And then he would change the lighting in comp, not like light passes, a bit more old school than that. So that's how all that stuff was done. Now, if I stop sharing again, well, we go back and share the other one like this. So I can, right, the Liev Schreiber digital double. This was done in a single working day. What we worked from, I don't know how many of you have ever seen the old, you remember the old scans they used to do with Microsoft Connects, right? And they always look really ropey and rubbish. That's what the scans we got were, because the technology was still quite new. So I opened these scans up and I'm like, well, we can't use that. We can't use it. It's going to need redone. So what we use the scans for was, in the case of Schreiber's face here, was just for the main forms. Like if I look straight from the front there, you know, you can see that one side of his face is vastly bigger than another. This cheekbone is lower down than that one. The center of his jaw here, you see there's a different angle on either side. So it stopped me having to look at all that stuff and spend a couple of days doing it. Now, obviously, all this was all textured. There was some epic cheating went on because we had some high-res photographs, but they were all full of shadows and stuff like that. So the likes of the head is a combination of photo projection with some quite, epic paint overs, and you can spot the paint overs if you look at the little tiny red dots here and there, which acts, people see it moving and they assume it's part of human skin, even though it's not. It just helps as a bit of an illusion. The rest of it, yeah, that's basically photo projection. There was some areas where there had to be some paint overs. The back was never seen. You can see some of the shadowing problems we were having on this. And some of the stuff like the straps never got finished off because they were never ever seen in a million years. And if something wasn't seen, then, it didn't get done. Simple as that. We didn't have the time. The film was done on a tiny, tiny budget. So there was 3 main doubles. There was the Marco, the Romana, this one, and obviously there was the Irwin one, which is the guy who goes through the airlock, right? Which we, did as well. But after a while, the thing is, Leo Schreiber, right, was the best known actor in the film. He had to be spot on. The rest of them, we could swap bodies for the 2 other male characters very easily. So the rest of it was just sculpting heads, 2 different heads, a different suit for a male, a different female suit, change the names over, and that was it. One of my favorite memories of this, I'll stop sharing because it's pointless sharing for this part. Right. Every now and again, there's a shot that you're working on. On paper, seems really easy. You think, oh, that's an hour tops. This shot I'm on about was one of those shots. So of course it had been allocated. Well, we'll give them half a day just in case. And I'm like, look, it's not going to take that. I'll do it while I'm doing something else. And it was in one of the shots, the female Romana character, they had taken the visor off because I'm guessing, and it's only guesswork, that it was reflecting the camera crew, right? And it was far too expensive to, take them all out in comp. So the idea was simple: replace the visor. So if you're thinking like I am, you're thinking, okay, make the visor, boom, boom, boom. We already had a CAD file, so that's sorted. It's going to be either a plastic, acrylic, or a glass. Put some fingerprints, some smudges over the top. Boom, done. It's a 1 second shot. So that's what I did. And it didn't work. It looked terrible. It looked wrong, even though it was physically correct. So we all stood around looking at this, trying to work out why this physically correct surface, in fact, we got to the point of even getting in touch with the people who made the props. What did you use for the visors? Still didn't work. We couldn't work it out. And it was last thing on a Friday, and I had a rule that nobody stayed late on a Friday because we'd all go out and relax in the local bar for an hour or two. And it suddenly struck me to have one of these crazy ideas. And what you see in the film for the visor replacements is actually an impossible material that can't exist in reality. It's reflective air. I basically thought, okay, well, let's just take the refraction out of the equation and just make it reflective. So the visors are all reflective air, and the film had lots of little things like that, that we hid in it. But I think this film was also a massive amount of it was down to the comp department. There was a lot of work put, as I say, by John O'Connell, by Garloff, Lagerbeck, lots and lots of people. It wasn't just me doing stuff. It was finding the best in a person, how to get the best out of them. And so, as a tribute to this team, which, to be honest, to this day, it's still the best team I have ever run in my life. In the last shot we ever had to do was the airlock shot, and it was me and John O'Connell. Everybody else had went home, and I said, John, you reckon we'll get wrong if I change something on this model? He says, well, only if they notice it, like. So I took the patch, this one that you see on here, and the model, you can't see it now because I'm screen, but the one on the breastplate, the red one, and I replaced it. So in the center of it, it had a world, and above it had this little circular design. I replaced that with a 3D Max teapot, and the names around the side I replaced with everybody on the crew. So it's not really visible in the shot at all unless you really freeze frame and had a huge telly. But all the lads knew it was there. And it helped make the work for them, you know. But it's been fun looking back on this, you know, nearly 8 years later, because there's so many things I'd forgotten about working on this one film. And it was such a magical time because we did impossible things on the world's tiniest budget. You know, times talking to the director in a kebab shop at 4 a.m, you know, about what we needed to do on the Monday. Things like crazy things. But it worked. And it was interesting because the stuff that was done with the rover in Wadi Rum, I know that they used as a basis on when they were doing The Martian. It was looked at when they were doing the Star Wars stuff because we got it right. And we only needed one light. Sometimes you don't need to overthink it. So that's basically me done there. I think I've talked for long enough, haven't I?
God, yes, Wayne, thank you.
Yes, Wayne. Brilliant. Thank you.
Thanks for talking English through some of it through as well.
Brilliant.
Wonderful presentation, Wayne. I really enjoyed it. You know, the work's incredible. I love the free-flowing form that you have of just creating this beautiful stuff. And obviously your creature work is incredible, and the digital doubles. I mean, I wouldn't even know where to begin with this stuff.
Well, normally it's just panic. You've got something to do, and you've got to make sure it's done. You know what I mean?
Yeah. So, Wayne, are you allowed to tell us what you're working on at the moment?
Yeah, because I'm working on nothing. Okay. Literally, I have no work in at all at the moment. Nothing at all. It's been quite scary since COVID kicked in. Because
been a slow year.
Well, it's like being freelance and being based only from home. A lot of places that I normally have dealings with have either shut down or are really on iron rations, and they're only doing stuff internally. So there's very little overflow. There's very little that pushes the envelope, because normally a lot of the time when people come to me, it's because they have a problem, you know, and they can't solve. Now at the moment they're playing safe. So I honestly don't know how it's going to pan out, you know, over the next year.
Well, I don't either, but I mean, as someone with your skill and background, hopefully, you know, we make it through. But yeah, tricky times for everybody, definitely. I don't want to end on a bummer there, Wayne.
Well,
sorry.
Yeah,
Sorry, I mentioned it.
I think the one bright thing out of the whole COVID thing, you know, sometimes you work on a project and you think this is never going to see the light of day.
Yeah.
And I worked on this very low budget TV show in the back end of 2019. They filmed it in an abandoned IKEA warehouse, and it was called Flora's Lava. In fact, I'm wearing the top from it at the moment. And I'd made this, and it was all these different rooms and blah, blah, blah. And I'm like, I can't see how this is going to work as a show. You know, but I'm like, you know, nice enough people to pay on time. It's really enjoyable work, you know. Next thing I know, and this was towards September last year, it turned out not only had it been broadcast, but it was the top show was it June or July on Netflix. It was the most popular show in the whole of Netflix around the world. And I was completely oblivious because I won't watch TV.
Wayne, it looks like there's a job offer for you already in the YouTube comments. So go through those. Someone's got something for you. It's Mars again. So, okay. And does anyone on the panel have any questions for Wayne there, please?
Well, I don't
Sorry, Wayne, how long did it take you to complete the whole film?
Right, I came in September. A lot of that was, it's what I call post-viz, not pre-viz, because a lot of it was just making sure the assets were right. The first shot wasn't started, I think it was towards the end of October. By March, the last 2 weeks with me and John O'Connell, we had 86 shots between us to do over the last 2 weeks, and we were done just literally about 2 days after St. Patrick's Day in March in 2013. And it was absolute full-on, straight at the wall. You know, everybody's working on multiple machines. It's the only way to do it. The comp department hated us because we were whizzing our chairs around a wooden floor on the floor above them. So it sounded like a train going past all the time. But yeah, it wasn't that long, really. Really wasn't. But most of it, in fact, the first 2 months was waiting for approval on the logos, because the legal department apparently over in the States were dragging their feet because every logo has to be approved to make sure it's not a real firm, which is a good idea, obviously. Unfortunately, we were sitting, twiddling our thumbs, not able to do anything or start any shots because nothing had been approved. You know, so yeah, didn't take that long.
Wayne, when we ran your film at the beginning, unfortunately the audio was not working, so nobody heard your talk through the show reel. Would you like to
rerun it?
Yeah, if you like, yeah.
If you don't mind, I think it would be really good for everyone to see the work and have your commentary.
Right, I'll try and look at this little square here and zoom.
Everything, so you can do.
Yeah, it's like the Marco Zombie. You know, it looks right. You know what I mean? There's other designs you could do which should have more reflectivity and specularity, but that wouldn't actually be right for what was needed in the film.
I think the raw kind of energy in it kind of works well. Anyway. The make it work kind of attitude.
Yeah.
Kind of
yeah, and it was capturing, making sure you captured the performance of the actors, you know, as well, which is important. Even though it's just screaming, I'm not an actor, you know, so you've got to make sure that comes through. But this is the infamous shot 1016, because you can see it starts from quite far away, gets very close to the cab. Everything is digital apart from the inside of the cab on that. In fact, any shots like this, you know, everything apart from the inside of the cab, that's all digital. That rover there. The lighting, that was the first shot I did. I just put a big block on one side, a huge, you know, box in Max, made it the same color as the ground, and off we went. The dust storm, which took 7 lifetimes to get to look right. You know, this has got one of the shots with the digital doubles. And as you see, they never really get beyond mid-distance. So you didn't need to put, you know, it didn't need to be too detailed. There was nothing to be gained from that.
Wayne, how long ago was this?
Started this in 2012 and finished, as I say, just after St. Patrick's Day in 2013.
So would it make a difference today with 4K and 8K, all of that stuff?
Oh, it would now, yeah. There's so many things. If I had to go back and if I had the same team now to redo this film and do exactly the same shots, I would do it a whole different way, and I would get it done in a quarter of the time. I really would.
For 4 times the cost, though.
Yeah.
Well, not exactly. Not exactly. Some of it was just a matter of clever thinking. You know, like there was the fact that if they hadn't realized that putting loads of 8K maps on a bolt, you know, when you had thousands of parts, was sending V-Ray through the roof, that if we used levels of detail, it speeded the render up, you know, this could have been a lot more expensive. You know, it punches above its weight for the budget that it had.
Absolutely.
Yeah, definitely.
I do think
Very
the night
nice.
shots especially stand up really well. You know, a lot of the night shots are done, as I say, by Giacomo. This is another one where that's everything apart from the cab is all digital, you know, and it's one of those things that I do have really good memories of. And the pit, so many versions of that pit, you know, I tried to save copies of all of it when I finished, but there was like literally about 100 terabytes of different versions of the pit. Each stone had, you know, had to be sculpted and everything else. And me and Glenn got to the point where we could rattle this off. But that shot there, that's one of the ones that sells that as a real thing with the torch. And that was just, you know, Yanko Slavov, who's one of the best trackers in the world, you know, tracking the heck out of that torch. So it was perfectly exact. And that shot there I did like just after my dinner around 10 minutes. That's the reflective air shot. Everything like that. The only thing it would look like is reflective air. Sometimes you've got to break the rules to make it work, you know. That was a lot of the stuff is extension, like the door. And you can see a lot of the stuff like the visors look especially well indoors. And there you go, there's the final shot with the little badge in the corner there with the name of the team on it. But I think a lot of it is how you manage a team of people, and it's no good going around throwing orders out. It's getting the best out of them. And that's how you get things done, not shouting at them, but find out what is their motivation, why are they doing it, and what makes them tick. I think we did manage that on that one.
Amazing.
Brilliant. No, that was great.
So, does anyone have any more questions for Wayne?
It's
no, just a big thank you, Wayne. Brilliant. I knew you were gonna kill it. It was great. I don't know why everyone else was worrying. Not even gonna swear and stuff. They didn't need to worry about
well, I did make a very conscious effort not to swear.
Yeah.
I swear a lot less now because my daughter's living with me. She's only 12. I'm trying to make sure she shouldn't grow up like talking like.
Well, we're on YouTube now. We have to make it child friendly.
Exactly. Yes.
I think
which is good because we're all children anyway, so it works out well. Josh, that's it, I reckon, isn't it?
That is, Wayne is our last presenter, yeah. So we can wrap up if no one's got any other questions. Thank you all very much.
We can wrap up. I would just like to just briefly hand over to Nigel. Nigel, what we're doing this year? What's 3ds London going to do this year?
Well, no, I'm not going to be doing the editing anymore on the show.
Is it? I said I would do that, so
Yeah,
we can
well,
edit out all of Nigel's audio oops. But we've
sorry.
got
I first would like to apologise to all our presenters.
no apology
and
needed,
the
Nigel.
audience.
Don't worry about it. It's fine.
If I picked up my headphones that's attached to the broadcast suite, I would cut the audio off. That's how crazy tonight's been. It's like it's a dodgy jack connection, brand new headphones, but as soon as that jack just wiggles, the system resets the audio and the whole broadcast thing gets reset, which was what I had to try and deal with whilst you were talking. Anyway,
so we were joking about gold-plated webcams for everybody the other day, but we'll get you a new pair of headphones. You can treat yourself. It'll be fine.
Yeah, it's not fair on the audience or the presenters. Anyway, this year and next month, Joanna is organising something special around International Women's Day. So that should be good. Olga, do you have any more input on that?
No, I'm afraid.
Don't be afraid.
Thanks. I'm afraid I don't know much about it. Only so briefly that she managed to secure some really, really good speakers, and it should be a very exciting event. I think I would encourage everyone to follow us on social media when we're gonna release more information coming up to the date.
Great, and there's some other.
That sounds good.
There's some tech talks where I'm talking to people in Africa and all around the world. We're trying to bring our community a little bit closer together whilst we continue to get Zoom fatigue.
Yeah, it's even worse than menu fatigue.
I did see, Simon, before in the chat, you were talking about the Isle of Man and jealousy over that.
I was, because they're allowed to go pub in the Isle of Man at the moment. So it's the Isle of Man and New Zealand are the two best places to live in the world right now.
Well, talking of film, New Zealand's film industry is booming right now. That it's because of the whole restrictions. Everyone's going there to shoot film, also doing a lot of post, a lot of visual effects work. James Cameron's playing with his little blue men, and it's so they seem to be having a good time.
Yeah,
we will continue to work from our living rooms until further notice.
Yeah. Well, okay. Thanks, Nigel. Massive thank you. Firstly, to all the panelists tonight. Josh for presenting, because I didn't have a clue what was going on tonight. So thanks, Josh. Thanks to all the other panelists jumped in and zoomed. Big thank you to all of our presenters. Amazing work tonight. It was a really hyped 3ds London, and quite rightly so. It was really good. And then the biggest thank you to all of our viewers on YouTube. Thank you very much for tuning in. We know that everybody is very, very bored of YouTube, Zoom, Teams meetings, all of this stuff, and it's very difficult to. We're nearly a year in now. That's been a long year, but I just want to let you know that 3ds London is going to keep talking through on Teams, YouTube, Zoom, all of this stuff, because as long as we have great presentations to share with you, we're going to still be doing it. And the 3ds London committee has a lot of good ideas for when we get back together, when we can all meet up again in real life as opposed to over a webcam. But we're not going to forget everything that we've done for this past year. We're going to try and make sure it's inclusive, and we can carry on the web presence as well. But it would be nice to physically cheers someone with a drink. It would be really good. Anything else, Nigel?
Just one more thing. Just continuing on that note, that it's with our supporters, including Autodesk and Chaos Group, we are talking to them about doing other things as well and bringing them into the equation. So it's, we're really grateful to have such great sponsors.
Yeah. By the way, there's an after party. We're all going to Zaps on Twitch. So we'll see you on Zap's channel on Twitch.
Great.
And Zap, I see you're in the chat. Maybe tell people where to find you. Unless people already know, it's Twitch. Just you look up Zap Anderson.
Come on, I'm 45 years old and I can find Zap on
there
Twitch.
We go.
Everyone else can. Don't worry about it, Nigel.
Right.
It's fine.
Let's wrap this up. Okay.
Okay. Take care, everybody. Thank you so much. Bye now.
Some of us will see you next month.